The problem of determining whether or not the probability that a person purchases a shirt on this visit to the website, whether or not that's in any way dependent upon the number of shirts that they've purchased on a previous visit, can be done through a statistical hypothesis test using the data that was collected by CatchMe running. And in particular, here is the data, or the table of transition counts, which they'd collected over the past 8 years. And we want to test the hypothesis of independence versus some kind of higher order dependence. So our null hypothesis is of this form. In particular, we notice that the rows of this P matrix are all the same. So regardless of how many shirts a person purchased before, the probability that they purchase X number of shirts on this visit is all the same. So we want to test that versus the alternative that it's not. And to do that, we'd use a statistical test, and in particular a chi-square test, which is a chi-square test for like a goodness of fit. And so we take each one of our observations, Nij, and we subtract from that the corresponding row sum and column sum multiplied together, divided by n, where n is the total number of observations. Take that difference and square it, and then divide it again by the ni dot j over n, and that's going to give us our test statistics of 72.0936. We then want to compare that to the distribution that corresponds to this chi-square test, which will be our chi-square distribution with 12 degrees of freedom. And the reason it has 12 degrees of freedom is we take the number of rows minus 1, which is 4 minus 1 or 3, times columns minus 1, which is 4, so 3 times 4 is 12. We then pick a value of alpha, and in this case we just picked 0.05, and so we want to get the area under this chi-square curve. 95% of the area is 21. So since our test statistic of 72 is much greater than 21, or it's much further to the right, we have evidence that we can reject the null hypothesis, or we have evidence that the null hypothesis is not true. So we reject H naught. Now, we could do further statistical testing of first order dependence versus some higher order dependence, which we don't show in this video, or which we haven't done here. But if we go ahead and assume that we have first order dependence in the process, then we want to get the P's, or the probabilities, for our P matrix, or our one-step transition probability matrix. And to do that, we need to get the maximum likelihood estimates of those probabilities. That is simply going to be the corresponding, or the Nij, divided by the row sum corresponding to that probability. So if we take, for example, this one, 0.18, which corresponds to P, I guess, 5.2, we would take 18 and we divide it by 100. And so that gives me 0.18. And I do that for all of the probabilities in here, and I get my maximum likelihood estimates.